All right, today's lesson is section 5.5, solving absolute value inequalities. So just like every other inequality, absolute value that we have solved, we have to create two different cases. All right, so the first case is exactly the way it is, except we're going to drop those absolute value bars. So it's going to be s minus 3 is less than or equal to 12. The second case, the left side is going to be the same, no absolute value bars. So s minus 3, remember we're not changing the left side, but we are going to switch the inequality or flip it so it becomes greater than or equal to, and that positive 12 is going to become a negative 12. So it's just like the equations. We always made the right side negative, but now we have to flip that inequality sign. So if we go through and solve this, we're going to add 3 to both sides. So we get s is less than or equal to 15. And then I'm going to add 3 over here. We're going to get s is greater than or equal to negative 9. Now we have to graph this. All right, so I'm going to have negative 9 on the left because it's smaller, positive 15 on the right. I'm going to put 0 somewhere in the middle, and then I'll do 16 and negative 8. All right, so now I have a closed circle at 15, and that's going to be shaded to the left. A closed circle at negative 9, that says greater, so that's going to be shaded to the right. So it looks like everything is going to be shaded in the middle. All right, so let's take a look at example number 2. Same thing, absolute value, inequality. So x plus 6 is less than 8, and x plus 6 is greater than negative 8. So subtract 6 from both sides. I'm going to get x is less than 2. And then if I subtract 6 on both sides, we get x is greater than negative 14. So now we need to go ahead and graph this. So negative 14 is on the left. Positive 2 is on the right. So we have an open circle at 14 now, an open circle at 2. It's greater than negative 14, but less than 2. So again, it is everything in the middle. So I want you to go ahead and take a second, try the your turn, and then come back. Do be careful on B because there is something fun for you on there to remember. All right, so that's what your first inequality should look like. And now we're going to go ahead and discuss the second one because it is something different. So it says we have the absolute value of p minus 5 is less than negative 2. So let's go ahead and do this like we normally would. P minus 5 less than negative 2. P minus 5 greater than positive 2. So I'm going to add 5 to both sides. So P is less than 3. And then I'm going to add 5. P is greater than 7. All right, we're going to go ahead and graph this. Nothing tricky's happened so far, so I wonder why I told you to be careful. There's 3. There is 7. P is less than 3. All right, so that's going to go that way. P is greater than 7. All right, that's going to go that way. We've had graphs that have looked like this in this chapter. But here's the thing. I do have this later on in the notes here. When I have the less than symbol, notice how when I had less than, everything was shaded in the middle. When we had less than here, everything was shaded in the middle. Everything less than there, shaded in the middle. So that means the less than or equal to go with the word and, meaning everything should be shaded in the middle. However, look at this one. That's not shaded in the middle. But when we have that word and, we want where the two intersect. So do these lines intersect anywhere? And the answer is no. So this answer is actually no solution because there is no value that makes both of them true. Now there is a much easier way to remember this. If you look back at the beginning, it said the absolute value had to be less than -2. Absolute values are always positive. So no matter what value I substitute in for P, it will never be less than a -2. So we could have looked at this and said, oh my goodness, it's no solution right away without doing anything. So do be careful at that. Be mindful. All right, so example 2. So example 2 says we have to solve this and then graph the solution set. Now what's different about this one, notice the inequality sign is going the opposite way. So maybe we should expect something to look like up top. So same thing, we're going to keep solving it. So 3y minus 3 is greater than 9, and 3y minus 3 is less than -9. Now don't forget, in this case, it's okay because I don't have my absolute value bars anymore. All right, so we are going to add 3 to both sides. So 3y is greater than 12, divide by 3, y is greater than 4. And then 3y is less than -6. Divide both sides by 3, we get -2. And I accidentally made an equal sign. All right, fix that up. Now we have to graph this. So we have -2, +4, less than -2, so open circle, shaded to the left, open circle at 4, shaded to the right. Perfect. So it was greater than. So let's go and write that note. So greater than and greater than or equal to is typically or, which that graph follows or. All right, let's take a look at this one. All right, I'm noticing something right away. I am noticing that I have an absolute value greater than a negative. So it's not less than a negative. So I can't have an absolute value ever be less than a negative. But what will an absolute value always be with a negative? It will always be greater than a negative. Always, always. So what we can do is say, hey, this one must be all real numbers. Let me write that in a normal marker. There we go. All real numbers. Because no matter what value I pick, whenever I take the absolute value, it's always going to be bigger than a negative. But let's go through and solve this so we can see what it looks like. So 2x plus 7 greater than or equal to -11, and 2x plus 7 less than or equal to +11. So I'm going to subtract 7 from both sides, and then divide by 2. Over here, I'm going to subtract 7 and divide by 2. Now let's graph this. All right, so I have closed circle there, bigger than -9, so that's going that way. Closed circle at 2, going this way. And now since it's or, that means it has to fit one of these. It doesn't have to be that part in the center where they overlap. It's any of the solutions. So if you notice, the whole number line is shaded. So that's how it's all real numbers. All right, take a moment, try the 2 your turns, and then come back. right, so you can see both your returns. I got a solution for the first one. Just going to go ahead and box my whole solution. And for the return, we ended up getting all real numbers. All right, so last example. Here is the chart I was telling you about that is very important. It tells you, it even has the equals there to remind you. And then these two, this one here, notice how we have less than and we have the word and then we have the greater than symbol and we have the word or. So those were the two cases I was talking about, and it even gives you the equal sign just as a reminder. All right, so last example, it's a word problem, but trust me, it's not that bad. So it says the average annual rainfall in California for the last 100 years is 23 inches. However, the annual rainfall can differ by 10 inches from the 100-year average. What is the range of the annual rainfall for California? So it says our average can differ by 10 inches. So differ by 10, that means it could be the average plus 10 or the average minus 10. So let's go ahead and do this. So I have 23. I have to add 10, and I have to subtract 10. So 23 plus 10 is 33. 23 minus 10 is 13. So that looks like my range could be 13 to 33 inches. And that's all we have to do there. I will say this is important. I just had to listen to a webinar the other day, and the lady said it was, I believe the number was 5. And it said, she said plus or minus 5. Or plus or minus, what did she say? Plus or minus 2. So then she said, so it could be as high as 7 and as low as 5. And she was a math person, so I was a little